Look at this exam. 6 questions, 2 days. The smartest teenagers on Earth from more than 100 countries, and most of them will not finish it. This is the hardest math test on the planet. And in the summer of 2024, a machine sat down and took it and walked away with a silver medal. Now, we've watched computers do amazing things, but this one is different. And here's why. In math, you cannot bluff. There is a right answer, and you have to prove it, step by airtight step, until there's nowhere left to argue. So, how did a machine learn the one thing that's supposed to be impossible to fake? Stick around. The trick is 2 helpers who are useless alone and unstoppable together. If you're new here, this is a series about the big ideas behind AI for the whole family. And look how far we've come. We watched AI learn to see, to read and write on an engine called attention, to show its work, to switch on brand new skills, to teach itself to think, to crack the origami of life, to play a game we thought was ours forever, to listen, and to dream a whole movie out of static, 12 episodes. And almost all of them have one thing in common. They get judged by your eyes. Today's AI plays a completely different game. First, the test. It's called the International Mathematical Olympiad, the IMO. Every July, the best young mathematicians from around 110 countries fly in for it. 2 days. 3 problems each day. 4.5 hours per day. Each problem is worth 7 points. So, a perfect score is 42. And these aren't worksheet problems. Some are so strange that most grown-ups can't even understand what's being asked. How hard? Take problem 6 in 2024, the meanest one on the whole test. Out of more than 600 of the planet's sharpest math kids, only 5 solved it. 5. So, when I tell you a computer cracked that exact problem, hold on to that number. But wait! Haven't we already met AIs that show their work? The chatbots from this series will happily walk you through any math problem. The catch? They're built to sound confident, not to be correct. Ask one a hard proof, and it'll give you a beautiful, fluent answer that is completely wrong with total conviction. That's fine for a chat. It's a disaster on an exam where every single step has to hold. So real math needs something a chatbot doesn't have. A way to never fool yourself. Here's the big idea. And it's beautiful. Imagine 2 helpers. The first is a dreamer, full of hunches. Ooh, what if you draw an extra line right here? Brilliant leaps. But sometimes totally wrong. The second is a stickler, a rule follower who never makes a mistake, but has 0 imagination. On its own, it just grinds and gets stuck. Neither one can win alone. But put them in a room together. The dreamer is a neural network. The same kind of attention engine we met back in the Transformer episode. You show it a problem, and from a lifetime of pattern soaking, it blurts out a hunch. Try this, add that, this. Shape reminds me of that one. Fast, creative. Exactly the spark a hard problem needs. But a hunch is just a guess. Somebody has to check it. That's the stickler. A symbolic logic engine. It doesn't guess. It only takes steps that are 100% airtight. If this is true, then that must follow. No exceptions. Hand it the dreamer's hunch, and it grinds out every rock-solid consequence. Problem? Left alone, it has no idea which hunch is worth chasing, so it wanders forever. Imagination with no rigor flails. Rigor with no imagination freezes. So you let them dance. The dreamer throws out a creative leap. The stickler checks if it's truly airtight and pushes it as far as logic allows. Stuck? Back to the dreamer for a new idea. Back and forth, guess, verify, guess, verify. Until together, they've built a proof. A chain of reasoning so tight that a computer can check every single link. Scientists call this neurosymbolic. Neural hunches plus symbolic rigor. Families can just call it the dreamer and the stickler. The first system to pull this off was called AlphaGeometry from the team at DeepMind. Its specialty, geometry. Triangles, circles, angles. And here's the thing every geometry kid knows. The hardest proofs crack open the moment you draw one clever extra line that wasn't in the picture. Finding that line is pure imagination. That's the dreamer. Proving everything that follows is pure logic. That's the stickler. Perfect team. But the dreamer has to learn somewhere. And there were almost no worked out geometry proofs lying around to study. So the team did something wild. They had the computer invent its own homework. It generated 100 million made-up geometry theorems and their proofs, completely from scratch. No human-worked examples at all. A machine teaching itself by inventing 100 million practice problems. Did it work? They tested it on 30 real Olympiad geometry problems. The previous best computer program, using older tricks, solved 10. AlphaGeometry solved 25. 25 out of 30. For comparison, the average human gold medalist solves about 26. So a machine had just climbed within one problem of the best young mathematicians alive. In geometry was just the warm-up. For the 2024 Olympiad, the team brought a bigger sibling, AlphaProof. For algebra and number theory, the stuff with equations and whole numbers. And it added a superpower. Every proof it writes is translated into a strict computer language called Lean. A tireless robot grader that checks each step and only stamps verified if the logic is flawless. No charm, no vibes. You literally cannot fake your way past it. And how does AlphaProof get good? The exact same way AlphaGo did, back in our Go episode. By playing against itself. It takes a giant pile of math problems, attempts proof after proof after proof, and whenever Lean stamps one verified, it keeps that and learns from it. Millions of tries, learning from its own wins. No human-worked solutions in the loop. Same self-teaching trick that conquered Go, now pointed at mathematics. Remember DeepSeek R1, the AI that taught itself to think and mutter, "Wait, let me reconsider? This is the next rung up." R1 showed you reasoning that looked right. AlphaProof produces reasoning that's been proven right. Checked, link, by a machine that cannot be charmed. It's the difference between an answer that sounds correct and one that simply is. So, the big day, the 2024 Olympiad, 6 problems. AlphaProof solved 2 algebra problems and 1 number theory problem. AlphaGeometry II nailed the Geometry 1. 4 out of 6. Final score: 28 points out of 42. The cutoff for a gold medal that year was 29. So it landed 1 single point shy of gold, a silver medal. The first time in history any AI reached medal standard at the Olympiad. And remember problem 6? The monster only 5 human kids on Earth solved? AlphaProof solved that one too. The single hardest problem on the test, cracked by a machine. Now, let's keep it real, because the team did too. The human kids get 4.5 hours. The AI got the problems hand-translated into its formal language, by people first. And while it solved some in minutes, one of them took it about 3 days of grinding. So this is medal level brilliance. Not quite medal level under real exam conditions. And the solutions weren't graded by the machine's friends. They were checked by real mathematicians, including a Fields medalist, the math world's version of a Nobel Prize. And it didn't ace everything. 2 problems, both a flavor called combinatorics, the math of counting clever arrangements, it couldn't crack at all, which is kind of wonderful. There are still corners of math where a 13-year-old's imagination beats the machine. For now. So, here's why this one's different from everything else in the series. Every AI you've met learned to be impressive at things we judge by eye. A believable picture, a fluent sentence, a real-sounding voice. Places were good enough to fool us was the whole game. Math is the opposite. You can't fool a proof. There's a right answer, and a machine can check every step. So this isn't an AI that learned to seem smart. It's one that learned to be provably right by teaming a dreamer who guesses with a stickler who never lies. The hardest test on Earth, built to find the one mind in a million that can't be fooled. And this year, that mind didn't belong to a person. It was a dreamer and a stickler, sharing a desk, 1 point shy of gold. See you next paper.